right, so many of you know both of us, so you, whoop.
Who are you?
I'm Slav Dushenkov. We follow appropriately after a discussion on pronunciation because we present a pronunciation problem here. People have difficulty with my first name, and people don't even want to try with Slav's first name. And even the last name is problematical in terms of the accent. Anyway, so let's move on here before we get yanked by Eber. So our project is, as you see, using mobile devices in the classroom, and it particularly pertains to anatomy physiology, but don't get scared. We'll emphasize the pedagogy and the results and very little on the anatomy physiology. So this is a problem which applies to most of the classes here at Hostos and probably at the other Bronx schools as well. Our course has no prerequisite, Anatomy Physiology 1, so people come in basically unprepared with handling science. Even in lab, they have problems focusing on things, and they're not prepared. They don't bring the lab manual if they've bought it. So combine that with today's world. This is a paraphrase of a Madonna song. I would sing it, but we all live in a material world. And students are digital natives, many of them, although many young ones surprisingly know less about technology than some of us oldsters. But most of them, as we learned from Tanver, have their own devices, and they're generally prepared to use them. So currently we use sort of the old school, sort of late 20th century, early 21st century methods. We use Blackboard. We use a Pearson proprietary software, Mastery AMP, which is available digitally online or on their computers and tablets and smartphones. YouTube videos, of course. I've spent a lot of time preparing video lectures with Tegrity, whose license isn't being renewed, Eber. And in any event, there are smart rooms. We do online testing, but that doesn't seem to do the trick. So the textbook is still, textbook and lab manual are still popular, way up there to study our course. People claim that they spend more time or more favorite to use their laptops, probably because they're looking at the digital copy of the textbook. But you see smartphones and tablets are way up there as well and will increase so. In terms of how the material is presented to them, lecture and lab are given as the favorites. But notice that text-based is like way down there. Students don't like to read their books. So in a course like ours, there's a huge amount of material. So this is a real problem. We see that students do tend to use AMP apps. They claim at least regularly, so very often or regularly, two out of three. So this is a access point. They're not reading their textbooks. They can't engage in lab. Well, they have their smartphones. Let's harness that use. Digital technology has a glow. We all find that glowing. In fact, I carried it up in my pocket. I didn't want to leave it there with Slav. So, so you bring out digital technology in the classroom, and students suddenly are interested. They're excited, and I'm just amazed that whatever the results in terms of exam grades or retention, aside from that, when you see them excited in the lab and focusing on something for 45 minutes or an hour, it's amazing. And I'm thinking, they're happy to spend an hour looking at the iPad screen of the skeleton but they ignore the actual $800 skeleton that's there. 2, 3 skeletons, loose bones. I say, please study the bones. Not interested. Oh, we have an iPad app. Ooh, iPad. So they're interested in that. So you go with the flow. You go with what they're interested in. And digital devices do have many benefits for learning. It can be individualized. The student holds the device in their hand. They control it. If it's a tablet, they can do group learning together. Active learning, because they can watch videos. They can move the things around, as I'll explain. It lends itself to different learning styles, which learning styles has or had been a buzzword for many years, and I guess still is, different learning styles. But yet students, we found, are not comfortable on their own using mobile apps in the class for A&P. And Professor Dushenkov suggests it's because we haven't encouraged them. They think of, as we heard from the other lectures, they think of the smartphone as something that's their own personal life, and that school is somewhere you're not supposed to use the smartphone, and maybe that's how we present it to them. Put your phone away. Don't use your phone. So we're starting to encourage smartphone use and tablet use, at least to study the things that we're supposed to be studying in class. So I think I more or less mentioned most of these things, the benefits of using digital devices and apps in the classroom. It draws them in with technology. If the information is readily available in the app, it stimulates active learning, and it's three-dimensional in its ability to turn the bones or the muscles around. And then the student can take the app home, at least with the free version that we engage them with, and hopefully we could find apps that are cheap enough or provide them for the students. So over the last several semesters, we developed a little pilot project, and we're applying for a small grant, and we hope to continue it next year. So this is the experimental group over a period of semesters. So we had lab classes. Some lab classes we gave iPads to the students for a particular discrete lab. In other words, we didn't convert the whole semester to iPads. We were just doing it in 2 lab periods per semester, the bone lab and the muscle lab. So at least in the first 2 semesters, the school didn't have full sets of iPads, and this semester they had carts with 30 or so iPads. But in any case, the early incarnations, students worked in groups on 1 iPad. They were encouraged to access the information on this free app called Visual Anatomy Free for Android, or Visual Anatomy Lite for Apple. And then they were told to fill in a worksheet to give them something to do to actually motivate them in the right way. And the control group did it the old-fashioned way. They used the lab manuals. They accessed information by turning pages in the lab manuals, but filled in the same worksheets. So this is a comparison. It in itself is a static picture, but it gives you the idea. So this is the old-fashioned lab manual way that everyone knows who went through a biology course. There's a diagram, there are labels. So this is the digital app, and unfortunately we don't have the we do have it, okay. So we will hopefully be able to demonstrate this on the app. But so you get to the screen, and so here's the musculature, and if you click on the blue cross here, it will highlight that muscle, and then in the information below it'll give the name of the muscle, and on this side it'll give all sorts of details about the muscle, and the same for the bones. So there the student has control over the information, they can access it very quickly. They can also turn the model around and look at it from the side and the back, and this is actually a kind of a primitive app compared to the more sophisticated, expensive ones that are out there. And this is the way the screen looks. There are other organ systems if we develop this further for the AMP sequence, students will be able to access all sorts of organ systems like nervous system, etc. So this is the worksheet that we developed for the skeleton. It kind of motivates the students to use the app for a goal-oriented purpose, to fill out different categories for each bone, how many bones there are, where the bones are located, where the bone attaches to other bones, but then don't stop there. Then fill in the worksheet, test yourself, and then test yourself on the skeleton model, or as we'll see, on the muscle model or on themselves. So they're given a task to use the iPad if that's the experimental group, or to do it with the traditional way. So here's simply the screenshot of the skeletal system, and here you can see if you pressed on this bone, which is the humerus, highlights, and it shows right here. Is this any different than the old-fashioned way where there's a label? Yes and no. No, pedagogically, but sexily, this is sexier. Ooh, it lights up. It's something different. And what is different is that all the information is now here. They don't have to turn pages and scan down the page to find it. They touch the bone, and the information is right there for them. So that is something different and better. So this is just another screenshot. This is the muscle worksheet, the same idea. For each muscle, for those not in the know, origin insertion are the two connection points, the two ends of the muscle, and actions, what kind of movement the muscle carries out. So here's Arnold Schwarzenegger. It somehow looks like him. So the muscle around the eye, that the squinting muscle, orbicularis oculi, is highlighted. And for the muscle, it has some lesser information, but there's a way to get more information if you want. And so here's another view, the chest muscle, and here are Hostos students, and they have the tablet, and they have the leg model. In this case, they have their book open also. I mean, we weren't going to be Scrooges and say in the experimental group, close your lab manual, we don't want you looking at it. I sort of said, I want to see how much you can get from the tablet, and in fact, they were quite happy not to use the lab manual. In fact, very often I have to beg students to open their lab manual in the lab period. But in this case, generally the experimental group of the tablets worked from the tablets and didn't work from the lab manual. And so then they used their tablets in other novel ways that we didn't even think of, taking pictures of the models, taking videos of the models, moving around the model in a kinetic format. We also found that the student, which is kind of obvious, but we didn't think about it, or I didn't think about it, till Professor Dushenkov did the calculations, that the students who worked with the tablet and the app were more efficient. They completed more work. They filled in the worksheet at a higher level than the students that had to look through the book. I mean, it sounds kind of obvious, but we made it easier for them. The information was right there on the tablet, whereas with the book they had to search for things more. Whether pedagogically they learn more that way, but in any case they were more efficient. The information flow rate, as I call it, was increased using the app in red rather than the lab manual in blue. And here's our little study. I wanted to use some statistics. I won't embarrass myself in front of the math department, but I wanted to use the t-test, and I spent like hours online trying to remember how to do it. And then Professor Dushenkov said, the study is not, there are some problems with the differences. In any case, so we did find a difference. There was so So we gave a assessment test, 35 questions, and the experimental group got a higher grade. It doesn't look much better, but it is, in our case, significant. So this was 54% grade. I mean, the grades are low in A&P when you look at averages. 54% versus 66%, or putting it as improvement, the experimental group with the iPad showed 122% improvement over the control group. Let's move along. Am I short of time here?
Yes.
Very short. So I think basically I talked about this, that the tech factor made everything sexier, the students focused more on this, they had active learning, and they seemed to retain more information, and we emphasized that these kinds of projects should run on multiple platforms and multiple operating systems, so they're not limited, because students want to use them on their own devices, and our plans for the future is just to scale it up, and the end is, the take-home point is technology should be a means to the end, but not the end in itself. Okay, that's it. Oh, but Professor Dushenkov will add a few words. And maybe we'll get the app to work.
We'll make the app to work. And I'll try to say only a few words because I have to take the class for pronunciation. After that, of course, we'll be able to talk freely to you. I have an easy job just to show you how this particular app works. We specifically took the app which is freely available, which is simple enough for our students. The problem we faced initially, all our students have mobile devices in the class. And most likely all of your students have mobile devices in the class. And if you are not engaging them with those mobile devices become distraction. They try to text, they try to take pictures. So at one point or another we decided, if you cannot fight it, join it. So we just took them and engage those mobile devices to our purpose, or educational purpose. Well, let them to take pictures, to take videos of the model. They're doing actually pictures of the slides through the microscope. I had no idea they could do that. They showed me how to do that. And then I caught one girl texting something, right? And I said, well, you're not texting in my class. It's not. Sorry, I'm just texting, not texting. I'm sharing my picture with the group. Yes, they're sharing the picture they took in the microscope with the group right now in the real time. And I said, that's wonderful. And then another girl shows me, well, you know, I set up a small app that we are sharing, which is the picture which they took after the microscope and the small description. Why not to do that? Let them do that. Why? So back to the mobile programs that we have. It's very simple, very straightforward, but it's simultaneously dynamic. It gives them opportunity to find what they're looking for easily, to get information easily. And actually, versions on the Android platform have the self-test also. And they engaged very much with this platform. We are at the beginning. The bottom line is to find the way to engage their devices to do things for us and for them. And that's my last word before I'll take the class. Thank you.